Ladies and gentlemen, this is Joe's Classic Video Games, back with another cool pinball repair video for you this evening. We are back here in the Bowery, or whatever you want to call this room, where we keep all of our parts and work on some of our complete basket case pinball machines. And we've had this Lost World here that we've been working on for quite a while. Now, if you didn't see the first video, this thing started out much worse. We put decals on it. We actually haven't even finished that video yet, but you've probably already seen it. But before we finish that video, we do them all ahead of time. Before we finish that video, I'm starting the second video because I need to work on the power supply on this thing. My brother Joe is doing a lot of the cosmetic stuff, and I am doing some of the electrical stuff. So we've got to work on the power supply. But here's the problem with the power supply. We don't have a power supply, so we've got to make one. So over there in all of our parts here, now a lot of these are monitors, but there's some pinball parts over there. This is actually sorted very well. You may not be able to tell. But there's some, you know, if you're an amateur, you wouldn't know that that's well sorted. But, you know, just me looking at it, I can tell. That's some good piece of stuff over there. I believe we have the parts to make the transformer part of the power supply. The transformer block and the rectifier board are in this stash somewhere. So I'm going to see what I can dig out so that we can put it in this Lost World. You can buy a brand new transformer and rectifier board assembly for these things. This is a 1970s Bally solid state pinball machine. But they're like $300. $300. Now I've got parts. If I've got the parts, we're going to cobble it together and make it work. I did this once before on a Flight 2000 pinball machine that we had that somebody stole the transformer out of. I mean, they probably owned it, so it probably wasn't really theft. They just borrowed it and put it in another machine. Probably. I don't know. But a lot of times people part these out. It drives me crazy. Drives me nuts. See all these parts? None of these parts are parts that we took out of machines. These are all parts that I found somewhere, and I'm trying to put them back in a machine. I don't know why everybody does it backwards. They keep parting stuff out. I'm trying to part it in. So we're trying to part this back together. If you didn't see the first video, the bottom of this is a Bally Lost World. Someone had parted it out, and the freaking head was missing, right? So this head is the wrong head, because the head is from a Stern Stingray that we had that the body was missing from. So we're using two to make one. So on the previous video, like I said, we did the artwork and things. Let's look inside of that head. I can show you what we're missing. And again, if you saw the first video, you probably saw it a little farther along than this because we haven't finished that video yet. Everything looks pretty cool in here. We had to do some repair back there where the cabinet was a little beat up, but as you can see, it's turning out pretty nice. We still got to put the rails on and clean them up. So this was a Stern Stingray, right? Which means that this lamp baffle board is what I call it, but whatever it's called, the lamp board is wrong. It won't be correct for the back glass that we need to put on it. So this is what's left of the Stern Stingray. You can see that it's still got the knocker coil up there. Now, why would I put a Stern head on a Bally body? Because it'll work, that's why. They're actually, the Stern games are copies of the Bally games. So it's wired very similarly, pretty much the same, and it uses the same boards. So on a Bally or a Stern, there is a transformer that sits right here. So if I can find in my stash over here one of these transformer blocks, or if I can find, I just need to find the transformer basically. I think I've got one. Let me dig a little bit. But basically we're trying to create the part here, right? That's the first thing that the power goes to basically. The power comes in here, goes to this line filter with a varistor across it, and then a couple lines run up here to a power switch underneath the cabinet. So if you reach behind the front leg, you can turn the power on and off. Okay, once it does that, it travels back and goes up into the cabinet through this hole and plugs into the power supply over here. Not that, this one. Plugs into the power supply. So we've got, are we missing a part? Where is our third wire? That goes there. That goes there. This is the power coming in. There's another one. Oh, it's the playfield one. I don't have the playfield in. Okay, yeah. I have to remind myself sometimes. Okay, so I need to find that part. That's the next thing that we need to piece this thing back together. And if we don't have it, we'll order it. But I'd love to not spend $300 on just the power supply inside of it. Well, as luck would have it, I do have a transformer. I thought I had one. We did one previously, like I said, on that Flight 2000, and I think I used one that originally had been in a Bally Dolly Parton machine. I think it was marked on it that it was for a Dolly Parton, and we figured out that it would work in the Stern Flight 2000. This appears to be a Stern transformer, but it would be for this same era of game, and it'll work just fine. You can kind of tell. I don't know how much you're going to be able to read that. Can you tell that it says 16B3? Right? 16B-3. 16B3. And then down below it, it says 37 dash, and then I think that says 7838. If that's what that says, the 7838 is a date code. It's the 38th week of 1978. So 16B3, this is actually a Stern transformer, which would have been exactly what is in our Stern head. Okay? And then I found this. Now, this is the little plate that mounts in the back. The transformer mounts right here. Right? And this big heavy plate mounts in the back in that corner. And that's the transformer assembly that we need. Suspiciously, this is also a Stern. The Bally ones look exactly like this. But this is actually a Stern. And that's a Stern. The wires are cut off this, and the wires are missing from this. So we probably picked this up from some place, and they had taken this. Probably originally was screwed right here. It's probably the same setup, right? And somebody, for whatever reason, took it all apart and then didn't do anything with it. And now I got to put it all back together. I don't know why people do that. This is what I'm talking about. Why in the world would you part it out and then not use it? I mean, I can understand stealing this because you got to put it in some other machine. I wouldn't do it, but if you got to do it, you got to do it. But why take it out and just set it somewhere? It doesn't make any sense whatsoever. Why would you take this and cut all the wires off of it to where I got to put them all back? I want you people to find out who did this, and then we're going to come get them. That's right, we're going to get you. All right, so there's a bunch of wires that go from here onto the back of this board. And once it's complete, basically this board handles all the connections. So that one little plug from the cabinet plugs in, I think here or here. One of the two. We'll figure it out. It can only go one way. It plugs in here, and then the other one goes out to the playfield, and the other one goes into the back box. So the AC voltage comes out, runs through one of these fuses, so it runs into a connector, runs through a fuse, and then is hardwired on the back to this transformer. The transformer transforms that wall voltage, which in our case will be 120 volts, into a bunch of other voltages. Those voltages are sent out of these lugs back into this board through wiring that's soldered on the back. You'll see all that here in a minute. And the wiring runs through more fuses and runs through bridge rectifiers and through resistors and all this stuff. And then once those voltages are rectified into DC, or one of them's left AC, or a couple of them, no, one of them's left AC. Once that happens, they're sent back out through these connectors to the playfield and the back box. And so it's just a really convenient way for them to create with this transformer all of the voltages that the machine needs to run. So it needs a 120 volts goes in, but the only thing in the game that uses 120 volts is this transformer. And so the transformer then creates separate voltages on these separate taps. So one of the voltages is like 43 volts that it uses to make all the solenoids work. The coils need 43 volts. One of the other voltages is 12 volts. That's used for some things, and then the 12 volts is used on another board to create the 5 volts that runs all of the IC chips in the game. Right? It's all digital, of course, solid state. There is a 6-volt voltage DC that is used to run all of the lamps in the game that are turned on and off by the computer, and then there is a 6-volt AC voltage that is used to run all of the general illumination lamps in the game that don't get switched on and off by the computer. So basically there are a bunch of bulbs that are always lit just so you can see general illumination. And then there's a bunch of volts that are computer controlled bulbs, not volts, bulbs. And then finally, there is a voltage of 220 volts that is sent up to the solenoid driver board to create the voltage for the displays. They're calling me. They've got to have me. So one of our problems is when they took this apart, they lost the little part, the little piece. This is another reason I don't like it whenever people part stuff out, because you lose parts. Leave it where it is, right? So they took this board loose so that they could cut all the wires off. And then whenever they did that, they lost the little heat sink that goes there and the 3 screws that hold this to the heat sink. So the way this was originally designed by Bally and then copied by Stern, this is a Stern, is these 3 bridge rectifiers are used to create DC voltages that get used in the machine. Now remember, the transformer doesn't rectify anything. All it does is it takes AC voltage and it transforms it to other AC voltages, right? So once it sends it up to here, those 3 bridge rectifiers rectify the voltage to make DC voltages. And you can see there's a space between those 3 bridge rectifiers, which are all in a line, and the actual plate. Right? I've got it exaggerated right now, but there's a little space there. And there is a little plate that goes in between all 3 of those and this plate that acts like a heat sink. So you can see where it was. You can see that there was a big square bar right there. And then there were 3 screws that go through the top, that go through those 3 tapped holes and hold it down. So there's a couple ways we can fix this. We could make another plate. I was planning on doing that, but I think I'm going to do something else. You could make another plate, basically to replace that, right? But the problem is, these are slightly undersized in the first place. It wasn't the greatest design to begin with. Sometimes these will burn up. And they're old, and they're probably a ticking time bomb. So we might get rid of those and change it, right? Because it would kill 2 birds, 1 stone. So I was going to do that. You could also probably take a nut from a leg leveler or something. Some kind of like a nut. Put 1 on each one, put 3 screws in it. We can probably find screws that'll fit. And the nut would connect that to that, but you're not going to get the best heat thermal dissipation that way. People that actually know about, and I'm not one of them, but people that actually know about this being a heat sink and know about the whole thermal properties of it and are big sticklers for that, they would go crazy if you put just a little round circle to transfer the heat from the bridge rectifier to this. So I don't want to do that on tape. So anyway, these things get really hot. And so that bar is so that they would be thermally connected to this plate, and then this whole thing would act as a heat fin, and it would radiate heat off of it. So instead of this being 140 degrees, since it's connected to this and it starts heating this up, this whole thing's 95 degrees, you know, and everything's lower. It wouldn't even get that hot, but you get my point. It basically, by spreading it out with more surface temperature, surface area that's exposed to the air, it'll cool down and keep this from being 145 degrees. If you run it with no heat sink, you run into problems. But there's a thing you can do. We could remove these three and mount them on the top. So that says plus, minus, AC, AC. It doesn't say AC, but the two that aren't marked on each one are AC. You can actually mount them on the top. It's a little harder because we're going to use bigger ones. And then you can use like 35 amp. These are, I think, 8 amp. You can use 35 amp bridge rectifiers. They run cooler because they're designed to handle 35 amps, and you're only running 8 amps or 7 amps or 6 amps or whatever through it, right? So they don't really overheat. Now, you could even mount heat sinks on top of those and everything else. But I think you'd probably be fine just mounting the 3 open-faced bridge rectifiers up in the air where they could just dissipate the heat on their own, because you're never going to get them anywhere near their working capacity of 35 amps, right? So I think that's what we'll do. And then that way we don't even need the screws that go in it. We don't need that little bar because we won't be using this as a heat sink. We'll just be using it as a way to mount this board. So the first thing I need to do is find some wiring so I can connect this transformer to all of the little spots on the back where the wires were. So see, like, that is a solder joint, right? Where they just cut the wire off. So I need to put a new wire in there and then run it to whatever tap over here that it's supposed to be on. The chance of screwing this up is through the freaking roof, right? Which is another reason they never should have done. It would be really easy to screw this up and get one of them that's supposed to be here connected there. And you could blow fuses, burn up this board, melt down part of the transformer. Why are they doing me like this? Once we get it all done, this was laying in the bottom of the machine. That is the guard that mounts around that thing in the back box so that you don't touch the high voltage and get screwed up. Right, so let me find some wire, and yeah, we'll see if we can just rig it up professionally, the proper way. Fortunately, in the bottom of the cabinet, and this thing has been horribly abused, but in the bottom of the cabinet, the original manual was in it, and more importantly, the original schematic package even. So this is how the transformer assembly was set up, and this is the Bally stuff, but again, the stern is pretty much exact. This is how the Lost World was originally set up. Now the first thing we're going to do is there is actually a set of jumpers here on the input of the transformer that changes the input line voltage. So if you look, this one has 1 and 3 connected and 9 and 11 connected. Okay? 1 and 3 and 9 and 11. That means it's set up for 115 volt line wall voltage. So we're going to change that just a little bit because in reality, over the years, they have raised the line voltage everywhere, right? So we're way up over 120 now. We're usually, when I check it, we're like 125, 126, something like that. But they only have a provision for 115, 120, 220, and 240. So we're going to set it up for 120. And the way you do that is you tie 1 and 3 together and 5 and 7 together instead of 1 and 3 and 9 and 11. And then you hook power to position 1 and position 5. Right? So they are actually showing that here. The power's coming in at 1 and 5. And they're saying that if you hook it up for 120, 1 and 3 should be connected, and 5 and 7 should be connected. Right? So they're showing you how they want it hooked up for 120, But again, this is a Stern. This isn't out of this actual machine. And I guess at the time, Stern was hooking theirs up for 115. Look at this. Do not like that. I don't like that. So that is the wax that's inside of the transformer. When a transformer gets really hot, one of the things it does before it burns up is it melts down, and you start seeing this. You'll see wax puddled underneath it. So we may end up in a situation where this thing is schlonged. If you see a little bit of it, usually it doesn't necessarily mean that the thing is shorted, but it means that it got hot. So it's possible to see this and the thing still be fine, but that's what that is. That's wax that has leaked out of that because it got so hot that it liquefied and started leaking out of the transformer. If the transformer got so hot that the coating melted off of the wiring, then somewhere in here the bare wires will be touching each other, and the transformer won't work properly anymore, and it'll be junk. Right? So hopefully we're not going to see that. Just that one little bit that came out, it's probably all right. It probably just got hot as crap and leaked out. It could have even been stored somewhere where the temperature was really hot and it leaked out. It's literally wax like from a candle, right? So it doesn't take a lot to melt it. But I still don't like to see that. So anyway, I'm going to fix those two jumpers, and that's step one. All right, so the wax was back here. That doesn't really mean anything, but I mean the location isn't all that significant because the wires wrap all through there. But there's another piece up here we're going to look at. Okay, so 1 and 3 is still connected. I didn't do that. I added a jumper to 5 and 7, and then I removed the jumper from 9 and 11 because we're not using it. It probably doesn't matter if you leave it hooked up, but it might, so I don't, So there was a strong wire connecting those together, and I've cut it loose. So this one does not touch this one now. All right? Okay, so that's good. So we're set up for 120. Look at this. There's a little more wax right here. A little bit here. A little bit here. Now, you see how much is wrapped in there. I don't know that you can tell. Like I was thinking, well, since it's there, maybe we could look at this. Maybe we could figure out what that line is and see that overheated. But I don't think you can do that because I think they're all wrapped around in there so many times. Any of them are probably going through there, so we don't know which one got hot. I'm a fairly lucky person if I don't jinx myself here. So usually luck breaks well for me. So I'm going to guess that this thing's still fine, but we'll see. All right, so first thing we got to do is start hooking up some of the wiring back where it goes. Now, how do you do that? Well, it shows it very clearly on here. So we just did this side. We just haven't hooked up the two wires yet, right? So the wire that runs from number 1 hooks to E2 on the board. E2, et tu brute. Where is E2? There it is. E2. So we need to clean that up, but that's where that wire would go, right? And it's soldered on the back. Are y'all getting scared? I'm not scared. So that white wire there was originally one of the AC wires. Right? And every one of them's labeled like that. So I'm going to add a few of them back in, and we'll go from there. All right, so I went ahead and put all of the wires on it. Going to every single test point. There's 12 of them. Not test point. E10, E11. I wonder what the E stands for. Probably makes some kind of sense. So it works pretty intelligently, really. It looks like a big mess, but really, if you look at it, 11 and 12 are a pair. So one of them runs here, goes through the fuse, goes to the bridge rectifier, and then the other side of the bridge rectifier 12 connects to. Right? And so one of them is 9 and 10. So 9 connects here, runs through the fuse, goes to the bridge rectifier, and on the other side of the bridge rectifier, 10 connects. It's the two AC inputs to the bridge rectifier. One of them is 7 and 8. So 7 connects here, runs through the fuse, and then there is a little... oh yeah, that's the lamp one. So the 8 is connected over here, which is on this big, huge ground. That one's an interesting one. If you look at the schematics, you know, you got to think about wire gauge. I'm using as heavy as I can get through the holes, basically. On this, you're running 3 amps through it before you blow the fuse. So this wire only needs to carry 3 amps. That's the main line into the game, too, the AC line. Right? But on the other side of that bridge, on the other side of that transformer, you've actually got a 20 amp fuse on the general illumination, because there's a ton of lamps on there, right? So it's a lot of amperage. So because of that, they have drawn it, and I love this kind of crap, because it's you can tell what they're saying. Look how they've drawn those 2 lines with an extra line. Why are they doing that? Because they're telling you, hey, there's 20 amps here. You might want to beef that up, right? So that's E7 and E8. If you look at E7, it's right there. There is actually another provision for a second wire beside it. So you could run 2 wires back to your lug. It wasn't like that from the factory, though. There were not 2 wires, though. And then E8 is over here on the ground. Or maybe that's not the ground. Is that the ground? Yes, that's the ground. E8 is over here on the ground, and there is a provision for 2 wires there too. So you could double that lineup if you wanted, but it's not like that from the factory, at least on the stern one. Okay, so I've got them all in. We're going to do a whole bunch of more updates to this board, but I think I'm going to test it first just to see what we're messing with, and if there's anything wrong with the actual rectifier board, it'd be good to know that before we start messing with things, right? Now, if you'll notice, there are test points, but they're past the bridge rectifier, and they're past the fuses. So if a fuse is not present, these test points won't work. All right, so I've got to get all the fuses right first, but we're going to put it in the cabinet and see if we've got all of our voltages, or if something's going to burn up or blow up, or if the transformer has melted down in the past. So what do you think? Is the transformer screwed up, and that's why they took it out of the machine? I don't think it is. I think they just took it out of the machine. All right, folks. So Joey was able to make me the little spacer. It's just a piece of aluminum with some holes drilled in it. That's exactly what the original one looked like. It's slightly thinner than the original one, but this board has a little bit of flex in it, and that won't be a problem. I've seen these before where people mounted them without the spacer and just screwed it down so tight that the bridges touched the plate. That's not a great idea. So you can see the space there. You can see the 3 holes below it. Another problem we have, though, is we don't have the correct screws. I'm going to use these, maybe with some nuts on the back, but the problem with that is you've got to be very careful that they're not touching any of those 4 pads around it, or it will short that to ground. So these originally had a little nylon spacer that went right under the head just for that, so that the head wouldn't touch any of those 4. Ironically, it kind of almost seems like it's touching this pad, which is the ground, which would be fine, but we're still going to do it. Okay, whoa! All right, so I tested the bridges. They seem fine. I tested the fuses. They're all fine, and I made sure that they are the right value. A lot of times you'll see these and the fuse will be the wrong one. I tested these diodes, and they're fine. I'm going to replace these, though, but we're just testing it for now. I checked this nice resistor. It's fine. I checked this resistor. It's fine. Look at this beautiful resistor here. Those are those cool old ones. Look at that. Look at that bad boy. They look like a Tootsie Roll Pop. So yeah, there's really not much to the board. There's the connections. I didn't resolder these yet. We'll do that later because all I want to do is plug in the one connector and then test our 5 test point voltages. And that will tell us if the transformer's cooked or not. I put some zip ties on the wires, and then once it's mounted in there, this thing goes like this and covers all of that up. Right. So I think we're looking pretty good. So we're going to slide it in the game, and we're going to try to turn it on the power and see if we burn anything up, and if we do, we'll fix it. All right, folks, so I have the pinball machine plugged into the wall. I've turned the power supply around, and all I have plugged in is that one connector. Okay, let me show you. Let me show you something. So this connector is the one that comes from the bottom. We're plugged into the wall, but we're turned off. However, there's a little bit of voltage on there. I've just got the one probe hooked up, right? That's ghost voltage, I guess, by the meter. I guess that's just how they work. So the very first voltage is actually a DC voltage. And the ground on these boards is this trace around the outside. So you can touch at the bottom of this resistor that's connected to ground. There was a big old solder pad right here where the that one wire was that we were looking at that can be doubled up. So we are turned off. We have 0 volts DC. I'm going to try turning it on. I think I'll step back a little bit just in case it pops a fuse or does something crazy. Seems all right. I can actually hear the transformer, just barely. I won't be able to record it where you can hear it, but there is a very low hum, which sounds good. Like, it doesn't sound like it's messed up or anything. Our wax was over here. Yeah, everything seems cool. So let's see. So test point 1, let's see what we get there. DC voltage. 5.9 volts. Very cool. So that's the DC voltage that they use to turn on all the computer controlled lamps. So we'll move over to test point 2. Very cool. 181 volts, that is the voltage for the display. Now that should be like 230 or 240, but it's low if you don't have anything else plugged in, because there's a, and this is DC voltage, there's a capacitor up on the solenoid driver board where that power goes. Ironically, we're going to regulate it back down to like 180 volts on that board, but it's working just fine. That'll rise up to like 240 once you plug that board in. So that's good. Test point 3. 13 volts. Perfect. That is the 12 volt, unregulated, 12 volt DC that gets turned into 5 volts up on the solenoid driver board. And then that 5 volts is used to run all of the IC chips on all of the boards. They also use the 12 volts for some things, like the LED on the MPU board and stuff like that. So, but the 12 volts is unregulated, so it's 13. All of these voltages will be a little high. But in the case of the displays, it's actually a little low. It's just one of those things where it makes sense that they're off. You're not looking for them to be exactly on the money. You're just looking for them to be there or be way off. If they're way off, something's going on. Test point 4 we'll skip because it's AC. Test point 5 is also DC. 43 volts. So that's the solenoid voltage, and it's about right on the money. I think it's supposed to be 43 volts. 42 or 43, but I think it's 43. Very cool. So we'll switch over to AC and then test point 4. 7.1 volts. That's supposed to be 6.3. That's for the general illumination. all of the lamps underneath the plastics and on the back box and all of that. So it's a little high because there's no load. We don't have any lamps plugged in. Nothing's plugged in. Or you know what? Actually, the cabinet is plugged in because we've got this plugged in. So if we had the coin door on the machine, the coin door bulbs would likely be turned on right now. So, in other words, the transformer works just fine. So we've got a good transformer. We're going to work on the rectifier board. This board's called the rectifier board. We're going to work on that just a little bit more just to make sure that everything's reliable. So I'm going to pull it back out to where we can mess with that just a little bit more. So the first thing that we're going to do is, on this schematic, if you look, this bridge rectifier that's created here by these 4 individual diodes is to create the voltage for the displays, 230 volts. So instead of using a bridge rectifier, they use discrete diodes because, I guess, because of the higher voltage, right? So these are problematic. They'll fry every once in a while. So I've seen many times where those have went bye-bye. One of these had already been replaced sometime in antiquity, right? So I've popped all of them out, and I'm going to put new ones in. They originally were 1N4004s. You can use, 1N4001, 2, I don't know about 1. Don't use 1. You can use 4, 5, 6, or 7 for sure. Okay, so I put in 4 new ones. Everything seems good. The last thing we're going to do is we're going to resolder all of these little connectors. Basically, these get bad solder joints on the end where they break loose from the board from people moving them around. Someone has already worked on this. Notice they put this jumper here. If you look, they are jumpering from these 2 pins to the second pin over here. So that I'm sorry, the first pin over here. So just think of the first pin there. Right? See that trace? They're mimicking one of those traces. And it's got to be that one. So they're going from there over to there. Let's see if that's correct. I didn't put that wire on there. Boy, this is a bunch of junk here, isn't it? Yes. Yes. See the first pin there? They have connected to the first pin there. So basically they are making this connection that's on this side of the board on the back side as well, just to make sure that all of that's connected well. So that's J2 pin 1 and J1 pin 8. J1 pin 8 and J2 pin 1. So it's the general illumination bus and the general illumination bus. So they, on the schematics, they have them drawn where they're connected back here. There is a trace running from there to there on the top of the board. It just happens to be how the board's laid out. So they've just put a jumper to make sure that connection is good. Nothing wrong with that. Okay, so I'm going to resolder all of those connections on the back, and then we'll be ready to mount this plate. I found some little insulator things that look like they may have came off something just like that I was able to put under. I used some different screws. I was able to put under the screw head, and it is all sandwiched up in there. I put some more heat thermal grease, sink gooey stuff on it. It's all good. So 2 will do you. If I had a third one just like that, I'd put it in there. But you don't need 3. Come on, there, people. Come on. There's one here and one here. You don't need 3. That was overkill. They were just doing that because they could, but you don't have to. You don't have. Come on, people. You don't need 3 of them. If you ain't got 3, you can use 2. Now one wouldn't work because it would hang. But maybe if you put it in the middle and then but you don't want to do that. Probably 2 would be better. let's be honest, 3 would be better, but I don't have 3. All I've got's 2. Come on, people. That's just as good as it's going to get, all right? Don't worry about it. Okay, so I cleaned up this area a little bit and mounted the thing in there. Now, it mounts slightly different than the one that was in there. Some of the sterns had a little U-shaped metal basket that it sat in down here, and then the plate mounted separately up here. So because of that, I had to mount it just slightly different. And because of that, I put the guard on here, but I put it upside down on purpose because there's a, see the little cut here? That is supposed to be down here. I made another one over here. Because if I had it the right way, the way this is mounted, it pushed this back far enough that it was almost touching those, the lugs on the transformer. So you don't want that. You want plenty of space all the way around it where it won't short anything out. Which means this is out a little farther, so it's on this brace here. But that's fine. That brace is just to stop this, right? So everything's cool. And it's not flush with the brace, it's back. So everything's cool, and I put the original little headgear back on it. And that's so that you don't touch the... that's so you can do this and not get shocked. Right? So, now, here is the most important part of the whole video. Are you ready? Are you ready? Now we need to see if the pinball machine wants to cooperate. Now, these are inanimate objects, but they were made by humans. Humans built this. They have the time and the heart that the humans put into it to build these things, and they're still doing it today. Stern Pinball still making pinball machines. Jersey Jack Pinball Company is still making pinball machines. Spooky Pinball is still making pinball machines. There's several other companies as well. So there's it takes a lot of time to build one of these, right? So, like I said, it's an inanimate object, so it can't do it itself, but they kind of help you, you know? So whenever this thing was designed, one of the things they designed was for all of these little beautiful light bulbs on the back box to come on just as soon as you turned it on. And we fixed the power supply. We saw that the voltage is there. These are some old looking bulbs, right? But maybe if we're lucky, maybe it'll decide to cooperate. We've done what we can to fix it so far. It needs to help us a little bit. So let's see if one bulb is still hanging on. What do you think? Fantastic. Now, that's the wrong lamp board because this is out of a not Sea Witch, the other Stingray. It's out of a Stingray. And so the stuff needs to be in a different position for Lost World. But as you can see, it's trying to do its part. At least the light bulbs are working. Now, most light bulbs will light up if you run juice through them, so it's not a huge accomplishment, but at least it's trying to help us. So with its help and your help coming back and watching on the next video, we'll get a little bit farther. So we'll see you on the next one. Hey, by the way, if you're not tired of watching us work on a Bally Lost World, check out this video, and we'll see you here in a couple days.